Alright, so in the last video, part one of this movement thing, we'd set this up to listen for keyboard events. In particular, we took our W, S, D, and A keys and gave them some meaningful names. So W and S move forward and backward, and D and A need to turn right and turn left. And then we set up this move character method, which takes in a task. Because we have a built-in task manager that will handle all of these things for us. And we're almost ready to run our first test, so have to remember to put that in the task manager when we get there. But it takes in a task, and anything that we give to the task manager, which just continually checks every frame, has to return task.continue at the end. CONT, abbreviation for continue. And we know eventually we want to get down to this set fluid position, which is identical to set position, except that the computer will know that we pass through every point in between if we do fluid position. So that's important for collision detection. But before we change our position, which is global variables, we have to rotate our character to determine what forward and backward are going to be. And we do those rotations with yaw, pitch, and roll, the standard transformations, linear transformations. And when they put Panda3D together, obviously Y was already used for the coordinates. So for yaw, they abbreviated that with an H. So our new yaw position, after we check our key presses, which we'll just assign either angular or linear speed, depending on if it's a turn or step key. So after we check those key presses, we can get our yaw value. Oh, I think there's a piece of dirt on my screen. That didn't look like an H. Yeah, it was right behind the piece of dirt, so it looked like an M. Sorry about that. So we'll get our current yaw value, and then we'll either add or subtract turn. We'll have to see. It just depends on which one of these should be positive and which one should be negative. But I'm just going to turn it and check and then adjust those negatives somewhere if it needs to be the other way. And once we have that, we can reassign that new yaw value to our character. Remember, yaw is the rotation about the z-axis. So our character is standing vertical, so turning left and right is rotating about that, around that z-axis. And and then we also have the pitch, which is rotation about around the x-axis, and roll is rotation around the y-axis. So once we get our new yaw, we can go ahead and go back in and set our yaw, pitch, and roll values to our new yaw, and then we'll leave the pitch and the roll the same. And at this point, we should be able to run a test and see if our character turns, but we need to pass this over to the task manager so that this happens every frame of the game. So up here in still in the initialize method, I'll go ahead and start the task manager. That way it will run the whole time we're in the game. And it's something built in. So self.taskmanager.add, and we're going to add this move character method to it. Self.moveCharacter. And then we have to give it a tag. We probably won't do anything with the tag, but some of the things happening in the background do use the tag for it. So we have to give it a pass in the method and give it a tag, and then the task manager will pass in a task, do this stuff at every frame of the game, and then return continue on that task when it finishes it. So we should be able to give this a test run and see if our character turns now. So I've navigated to the right folder already, so we're in Python test3.py. Uh-oh, got a typo. I haven't actually done that yet. I'll comment out that line. I just jumped ahead to put that in spot. Okay, so our game loaded up. If I push the D key, Oh, our character turns right, so that looks good. If I push the A key, the character rotates left. So D and A rotate our character, so we're changing our yaw value, and that's how we turn back and forth. So now we want to step in that direction. And we set up the key press so that if the W or S is pressed, we know we're stepping, but we have a 3D vector. So our position is given in global coordinates, and yaw, pitch, and roll is about our character, so obviously that's local coordinates. So we need to do some conversion and convert between that local, rotate a global vector by that local angle we rotated, which means some linear algebra. So I opened up Paint over here just as hopefully a quick reminder on how to do this. Hopefully you've seen this before. So if we have some vector, x, y, and z, to rotate it, there are some rotation matrices, standard rotation matrices. So for yaw, our rotation matrix is going to be cosine theta, negative sine theta, 0, because we're rotating around the z-axis, so it's actually not changing. Then our second row is sine theta, cosine theta, again 0 because we're rotating around the z, so that's not changing. And then 0, 0, 1. So we'd carry out that multiplication, and so it's matrix multiplication. So this column times this row gives us our new x value. And then the second, or I said that backwards. The first column, first row times the first column gives us the first row of the new matrix. Then the second row, this row times this column gives us our second value in the matrix. I guess I could put little prime symbols on there. And this row times this column give us the third value of our Z matrix. And so with all these zeros, there's kind of a shortcut. So we can see our x's are going to multiply by cosine, then sine, and our y's multiply by negative sine, then positive cosine. And with these zeros, we can kind of use this shortcut and go straight across. So we get to our new x times cosine theta, then y times negative sine theta gives us our new x. And y, if we go straight across, x times sine theta, y times positive cosine theta gives us our new y. And our z is not changing because we're rotating around that axis. Right? We just end up with z times 1 to get there. So that's the multiplication we need to do. So if we come back over here, it's going to look a bit of a mess. And we're coming on 10 minutes, so that explanation lasted a minute. So that's our some matrix row multiplication. Where's something I can see better? Is there an arrow? Well, not really seeing the cursor. Oh yeah, it's going to be circled. So we take this vector times this rotation matrix to get, a final, the resultant vector. So we need to set that up in our code, which we're coming on 10 minutes, so I'll go ahead and do that in the next video. Type all this up, and then this is cosine and sine. So we also have to make a slight adjustment to make sure we're in the right portion of the unit circle. if you remember back to basic trigonometry, we actually need to be between negative pi halves and pi halves. So we have to make that adjustment as well. So I'll do that in the next video since we're coming on 10 minutes here. So I guess this is a three-parter going over explaining the math. But hopefully that makes sense if you've seen matrix multiplication before. And if you have not, you'll be able to just copy this formula that I type in the next video, because it's always the rotation around the z-axis is always going to be that same formula in the end. So we'll do that in the next video.